For centuries, Western civilization has built its understanding of the human mind on one big assumption: your mind and body are separate. This paradigm assumes that your thoughts somehow float in an ethereal mental space, disconnected from the messy biological machinery of your brain. Philosophers dubbed this the mind-body problem, and scientists have treated cognition like software running on biological hardware. Educators, too, have taught abstract concepts as if they exist independently of physical experience. This assumption is completely wrong. Revolutionary discoveries in neuroscience reveal that your most abstract thoughts are not hovering somewhere around your body. They live in the same neural circuits you use to move, see, and feel. When you understand the concept of grasping an idea, your brain literally activates the same regions involved in grasping objects with your hands. When you think about emotional warmth, the neural areas that process physical temperature light up. When you contemplate the future as something ahead of you, your brain engages the same spatial processing systems you use to navigate forward through space. The boundary between mind and body was always an illusion. Now you can think beyond it. The neural revolution began quietly in research labs across the world, as scientists over recent decades made discoveries that would overturn centuries of thinking about the human mind. In the 1990s, Italian researchers studying monkey brains made a remarkable discovery. They found neurons that fired both when a monkey performed an action and when it simply watched another monkey perform the same action. The discovery of mirror neurons suggested something radical. The brain does not separate perceiving something from doing it. This was just the beginning. Brain imaging studies soon revealed that when people heard action words like kick or lick, their motor cortex lit up in the exact same regions that control those physical movements. In other words, your brain treats the word kick as if you were actually kicking. The neural machinery for action and the neural machinery for language were not separate systems after all. More startling discoveries soon followed. Researchers found that when you think about the past, your brain activates regions associated with moving backward through space. When you contemplate the future, the same neural networks that guide forward movement fire up. Time, it turns out, is not some abstract dimension your mind floats through. Your brain understands time by borrowing from your embodied experience of moving through space. There's a similar parallel when we think about temperature. When people hold warm objects, they judge others as having warmer personalities. When they hold cold objects, they perceive social situations as chillier. The neural pathways processing physical warmth directly influence how you understand emotional warmth. Your brain does not maintain separate filing systems for literal and metaphorical temperature. And it doesn't stop there. Scientists also discovered that people literally embody mathematical concepts. When you add numbers, for instance, your attention shifts rightward along an imagined line. When you subtract, it moves left. Children who struggle with spatial reasoning also struggle with arithmetic. Essentially, your understanding of mathematics emerges from your bodily experience of navigating space and manipulating objects. As each discovery built upon the last, it created an overwhelming body of evidence. The brain reuses neural circuits originally evolved for bodily functions to construct abstract thought. Vision networks create insight. Movement pathways generate understanding of change. Touch circuits build social connection. These findings demolish the traditional view of cognition as disembodied symbol manipulation. Instead, thinking is a fundamentally embodied process. Your most sophisticated thoughts emerge from the same neural machinery you use to navigate through a crowded room. The scientific revolution was complete. The mind-body divide was not just wrong, it was a neurobiological fiction. Consider an astonishing trajectory. From your very first breath as an infant to the founding principles of democratic civilization. The neural networks that helped you survive your earliest moments eventually give rise to concepts like justice, freedom, and human dignity. The same biological systems that regulate your heartbeat and breathing actually generate the intellectual frameworks that created something as abstract as the United States Bill of Rights. This is not poetry, it's the remarkable story of how embodied experience becomes abstract thought. Your journey begins with the most basic bodily experiences. As an infant, you learn foundational patterns through physical interaction with the world. You discover containment by being held, by putting objects in your mouth, by experiencing the boundaries of your crib. You understand force by pushing and pulling, through the resistance of objects and the support of surfaces. You grasp paths by crawling from one location to another, or by following the trajectory of a rolling ball with your eyes. These simple bodily experiences create what scientists call image schemas. These are basic structural patterns that become the scaffolding for all future thinking. The containment schema emerges from countless experiences of being in and out of spaces, containers, and embraces. The path schema develops from moving your body through space and tracking movement around you. The balance schema forms as you learn to sit, stand, and walk. Here comes the extraordinary leap. Your brain doesn't abandon these bodily patterns as you mature. It transforms them into the architecture of your abstract thought. The containment schema that began with physical boundaries becomes your understanding of categories, groupings, and classifications. The path schema that emerged from crawling evolves into your comprehension of logical arguments, life trajectories, and moral progress. The balance schema that developed through physical equilibrium becomes your sense of justice, fairness, and social stability. When the framers of the U.S. Constitution conceived of checks and balances, for instance, they were not inventing political theory from nothing. They were extending the embodied balance schema that every human develops in learning to navigate gravity and physical stability. When they envisioned rights as protections that shield individual liberty, they were building on the containment schema rooted in the most basic experiences of safety and boundary. Your capacity for moral reasoning, political philosophy, and social organization all emerge from these foundational embodied patterns. The ventromedial cortex in your brain, which processes your emotional responses to physical threats, also evaluates ethical dilemmas. The neural networks that coordinate your immune responses to biological dangers also generate your reactions to social injustice. This transformation from embodied experience to abstract principle reveals the profound continuity between your biological existence and your highest intellectual achievements. Democracy itself emerges from the same neural foundations that keep you alive and help you navigate the world. Your brain is running a sophisticated translation system that you have never consciously learned. Right now, as you process these words, neural circuits are automatically converting abstract concepts into familiar bodily experiences. When you hear, for example, that prices are rising or feel your mood is up, your spatial processing networks activate as if you were moving upward through space. This is not a linguistic decoration. It's your brain's fundamental operating system making sense of complexity. Your brain combines basic patterns like these into what scientists call primary metaphors, systematic mappings that allow you to understand one domain of experience through another. The containment schema merges with your experience of quantity to create the metaphor that more is up. The path schema joins with your sense of time to generate the understanding that the future is ahead. The force schema connects with causation to produce the idea that causes push effects. But your brain doesn't stop with simple one-to-one mappings. These primary metaphors combine into complex conceptual frameworks that structure entire domains of human experience. Your understanding of argument emerges from the fusion of multiple embodied patterns. Arguments are buildings with foundations and structures. Arguments are journeys with paths and destinations. Arguments are wars with attacks and defenses. Each metaphor highlights some aspects while hiding others, shaping not just how you talk, but how you think. Consider how the metaphor of time as money restructures your entire relationship with temporal experience. This conceptual framework, built from schemas of containment, exchange, and scarcity, transforms time from a flowing river into a finite commodity. You spend time, save time, waste time, and worry about running out of time. This metaphorical mapping creates behaviors, institutions, and entire economic systems built around temporal efficiency. The profound implications become clear when you realize these metaphorical frameworks shape perception itself. Cultures that understand time as circular rather than linear develop fundamentally different relationships with planning, memory, and progress. Societies that conceptualize the self as bounded versus interconnected generate distinct approaches to responsibility, identity, and social organization. In other words, your metaphorical thinking doesn't just describe reality, it creates the very reality you inhabit. The neural machinery that helped you navigate physical containers, paths, and forces now constructs the conceptual landscapes of law, science, art, and human relationships. Every abstract domain you can imagine emerges from the creative recombination of these ancient embodied patterns into new metaphorical architectures. Every second of your waking life, your brain is running sophisticated simulations that you never consciously notice. As you navigate through a crowded supermarket, for instance, neural networks are constantly modeling potential futures. Your brain simulates stepping left to avoid the shopping cart coming toward you. Maneuvering around the cluster of people blocking the cereal aisle requires simultaneous awareness of speed, obstacles, and the force necessary to turn your cart to the left or right. These are not abstract calculations. They are embodied simulations that activate the same motor circuits you use for actual movement. This simulation system operates far beyond simple navigation. When you consider whether to ask your boss for a raise, your brain runs embodied scenarios. The spatial dynamics of walking into the office, the bodily tension of a difficult conversation, the physical sensation of confidence or anxiety. When you plan your weekend, you simulate the embodied experience of hiking that trail or cooking that recipe. Every decision emerges from neural simulations that recreate elements of physical experience before you act. This refutes more than a century of philosophy to reveal that language does not, in fact, create thought. Thought creates language. Your ability to communicate emerges from the same embodied neural machinery that generates your private understanding. Simulation. When you speak, you aren't manipulating arbitrary symbols according to formal rules. You are coordinating embodied simulations between minds. Consider what happens when you tell someone about your difficult morning commute. Your brain doesn't retrieve stored sentences and transmit them. Instead, you recreate elements of your embodied experience, fighting through traffic, the time pressure of running late, the physical tension of frustration. Your listener understands not by decoding linguistic symbols, but by running embodied simulations in their own neural networks. Communication succeeds when both minds activate compatible patterns of embodied experience. The implications transform our understanding of language itself. Grammar doesn't exist as an abstract system. Grammatical structures emerge from the same image schemas and metaphorical mappings that organize all human thought. The subject-verb-object pattern reflects the embodied schema of agents acting on objects. Prepositions like in, on, and through map directly onto spatial relationships you navigate. Verb tenses emerge from your embodied understanding of time being like movement through space. This embodied foundation of language explains why recent decades have witnessed a profound shift toward experiential and participatory approaches to knowledge. From hands-on learning in education to design thinking in business, from somatic practices in therapy to maker movements in technology, humans are rediscovering what neuroscience now confirms. Understanding emerges from embodied engagement, not abstract analysis. The rise of large language models and deep learning systems has created an unexpected mirror for understanding human cognition. ChatGPT and other AI systems can generate remarkably human-like text, solve complex problems, and engage in sophisticated conversations. But they operate through pure statistical pattern matching across vast datasets with no bodies, no sensory experience, and no embodied understanding of the world. This creates a profound puzzle. If thinking is fundamentally embodied, how can disembodied systems appear so intelligent? The answer reveals both the power and limitations of current AI. These systems excel at manipulating the surface patterns of language because human communication, while grounded in embodied experience, leaves statistical traces in text. When millions of people write about concepts, their embodied metaphors create detectable patterns in language. AI systems learn to reproduce these patterns without understanding their embodied origins. But this statistical mimicry breaks down precisely where embodied understanding matters most. Current AI struggles with genuine creativity, contextual reasoning, and the kind of flexible problem-solving that emerges from embodied interaction with the world. They can describe riding a bicycle, but can't balance on one. They can write about the feeling of sand between your toes, but have never experienced texture. They manipulate symbols without the embodied simulations that give those symbols meaning. This is why the path toward truly intelligent AI may require embodied experience. Robots that move through physical environments, manipulate objects, and navigate spatial relationships develop different kinds of understanding than purely linguistic systems. The most promising AI research increasingly focuses on embodied agents that learn through interaction with the world. For humans, this moment in AI development offers profound insights into our own cognition. The contrast between statistical pattern matching and embodied understanding highlights what makes human intelligence unique. Your capacity for meaning emerges not from processing information, but from living in a body that moves, feels, and acts in the world. As AI systems become more sophisticated, they serve as a mirror reflecting the irreplaceable value of embodied human experience. The future of intelligence may not be about creating minds that think like computers, but about understanding how bodies create minds that no digital system can replicate.